Experts are certain that we will divide the era of space exploration into a time before and a time after the James Webb Telescope. This is hardly surprising, given that the discoveries made by the most powerful telescope of all time have already shown us that our current models simply do not match cosmic reality in detail. Webb has already detected a whole range of structures that, according to our understanding, should not exist at all in this form. This refers in particular to the objects that formed immediately after the so-called Dark Age and which simply appear much too large and massive for their early formation time. And so it is that experts are increasingly admitting that our established ideas about the early universe are hopelessly outdated and that there is still a long way to go before we will have understood this confusing era. Of the thousands and thousands of objects that sparkle at us on starry nights, it seems inconceivable, and yet the universe was once a place of absolute darkness. Indeed, the cosmos has been through a lot since its beginnings 13.8 billion years ago. In the first 380,000 years after its creation, the universe was initially a hot and dense ionized plasma. However, it then cooled down to such an extent that the protons and electrons filling the universe were able to combine to form neutral hydrogen atoms during the so-called Dark Age. However, there were no sources of light, no stars or galaxies, just a transparent, neutral space filled with a dense fog of hydrogen gas. That the cosmic light was switched back on in the period that followed is thanks to the first stars and galaxies, which emerge about 100 million years later and gradually reionize the gas through their ultraviolet radiation. In the course of this, the electrons were separated from the protons, leaving them as free particles. Among experts, this era is known as the cosmic twilight, and although it is still surrounded by some huge question marks, the James Webb Telescope has already shown us that it played out quite differently than previously thought. Because there is one thing we must not forget, specially developed for infrared astronomy. One of the main tasks of the $10 billion device is to look into the most distant and thus oldest corners of the cosmos and to catch a direct glimpse into the immediate phase after the Dark Age. And the results are quite astounding. If you are even a little bit interested in the subject, you will have heard that Webb detected 6 early galaxies as early as 2023. Which embody nothing less than an astronomical impossibility. More specifically, this refers to the fact that the structures already existed 500 to 700 million years after the Big Bang, and, despite all this, were already as massive as our Milky Way is today. Accordingly, all 6 galactic primitive babies contain more than 10, and in one case even more than 100 billion solar masses of stars. To explain the existence of such massive galaxies at this early stage, either the density of matter in the young cosmos would have to be 2 to 5 times greater than predicted by the standard cosmological model, or the galaxies would have to have grown in a way that is completely unknown to us. In view of this, it's probably not particularly surprising that the galactic mysteries henceforth became known as universe breakers. But in truth, this was only the prelude to a series of no less confusing Webb discoveries that have since given scientists a severe headache. On the one hand, there is the galaxy named JADES GSZ 14-0, which entered the cosmic stage as early as 290 million years after the Big Bang, and which also presents itself as much too large and starry for that time. How a galaxy could have formed several hundred million solar masses of stars in less than 300 million years is an open question, and it's worth considering that fact again. Before the James Webb Telescope revealed the true face of the young universe, experts assumed that there were only tiny, low-mass baby galaxies at that time. And in theory, of course, this also makes sense. After all, our models suggest that so shortly after the Big Bang, there simply wasn't enough normal matter to form so many stars in such a short time. And yet, there they are, just like the red monsters that were detected a few weeks ago and once again challenge our understanding of early galaxy growth. Is the standard model of cosmology wrong? In view of the constant stream of new surprises that the universe now reveals with increasing regularity, a fundamental question arises. if so many structures are found out there that blatantly contradict the standard model of cosmology? Could it be that this model is simply wrong? Now, to find out for sure, a research team led by Mangan Shia of the University of Geneva has set out to systematically search for the early outlier galaxies once again. In the course of this, the scientists evaluated the data collected by Webb's near-infrared spectrometer and IRCam, and in it, they actually discovered 36 more massive, dust-shrouded galaxies that existed around 1 billion years after the Big Bang. Ultimately, Webb's high-resolution spectra penetrated the dust veils that made the galaxies practically invisible in the optical spectrum, whereupon the team set about analyzing the corresponding stellar mass and its relationship to normal and dark matter. In the course of this, however, 3 objects should stand out clearly from the galactic mass, and because of their astounding size and red color, the astronomers named them the Red Monsters. In fact, the members of this trio are almost as massive as the Milky Way, and they also present themselves as extremely prolific star formers. Expressed in figures, this means nothing more than that the respective star formation rates amount to 795 to 1,300 solar masses per year, which, however, only further deepens the already existing mystery. To produce so many celestial bodies in such a short time, the 3 red monsters have to convert much more gas into stars than usual. To do this, the researchers state that their so-called conversion rate is 2 to 3 times higher than would be usual for the most efficient star formation in younger galaxies. This is because such galactic youngsters can only use around 20% of the available gas for star formation. But the red monsters have apparently somehow managed to circumvent the numerous processes that normally limit the efficiency of star formation. But what does this discovery mean in a larger context? Well, for the standard model, it provides encouraging news. After all, an impossibly high density of matter in the young universe is not necessary to explain the existence of the early massive galaxies. At the same time, however, the red monsters suggest that star formation and galaxy growth took place quite differently back then than they did later. According to Shia and her colleagues, they provide strong evidence that the cosmos was 2 to 3 times more efficient in terms of galaxy growth in its early days. But what enabled it to do so is still completely uncertain. What is certain, however, is that the red monsters mark the beginning of a new era in the study of the early universe, and that not only the cosmic past but also the present appears extremely confusing. Webb shows that the universe is expanding too fast. As we all know, the universe has been expanding continuously since the Big Bang and at an ever-increasing rate. To explain the accelerated expansion of the cosmos, experts have postulated dark energy, which is thought to act as a kind of counterweight to gravity and about which, apart from that, practically nothing is known. However, the exact rate at which the universe is currently expanding is hotly debated, even though we actually know a fundamental cosmological constant, the Hubble constant, which indicates precisely this. Unfortunately, there is a significant problem here. The standard model predicts a Hubble constant of around 67 kilometers per second per megaparsec. To put it in context, 1 megaparsec is about 3.26 million light-years, which, in other words, means that the speed at which galaxies are moving away from each other in space increases by 67 kilometers per second every 3.26 million light-years. Well, at least in theory, because real space observations have shown, on the basis of supernovae, gravitational lenses, and variable stars, that the value of the Hubble constant in reality is 73 kilometers per second per megaparsec. And just to be clear, this corresponds to a whopping 20,000 kilometers per hour per megaparsec. But how can such a dramatic discrepancy be explained? Could it be the result of measurement errors? Well, that's exactly what Adam Rees's team at Johns Hopkins University in Baltimore wanted to know when they used Webb to re-examine the data collected by the Hubble Space Telescope. But the bottom line of the evaluation of the largest Webb data set to date was that the universe, in reality, simply does not do what it should in theory. This time, too, The overall result yielded a Hubble constant of 72.6 kilometers per second per megaparsec. According to Rees, everything points to the fact that our understanding of the cosmos is simply incomplete. It's possible that we have so far overlooked a component that gave the early universe an unexpected boost after the Big Bang. But at the same time, it could also be that dark energy has unknown properties or that exotic particles lie dormant out there that could solve the problem. And now we'll show you how to crack the problem of your missed videos. Simply click on the thumbs up and subscribe to stay up to date. From now on, we'll see you soon.